Hello, and welcome back to the Inside Java podcast, a podcast about everything Java directly from the team that builds Java. In this episode, to celebrate the release of Java 18, let's hear directly from the team that works on some of the JEPs in that release. I had a conversation with Naoto Sato on JEP 400 UTF-8 by default, and Michel Trudeau on 413 code snippets in Java docs. Also, we've had recent episodes on both 408 and 421 with Yulia Bose and Brent Christian. Rather than ask them to repeat themselves, I'll grab some highlights from those conversations. Okay, let's jump right in. My first guest is Naoto Sato from the Java Platform Group to talk about JEP 400 UTF-8 by default. Naoto, welcome to the show.
Thank you for inviting me.
Why don't you start by introducing yourself?
Yeah, sure. I'm Naoto Sato, working for Oracle Java Platform Group for I don't know how many years, like 20 or something. Pretty much working in the core libraries, mainly internationalization or Java.time or that area.
Uh-huh. Have you been in the US for the whole 20 years?
Yes. I came here around just before 2000. From there, I've been based in the Santa Clara area quite a time.
Well, I don't know if you noticed from my last name, I'm half Japanese, but I'm not a very good
I noticed that.
Not a very good sansei because I actually don't speak any Japanese, but I would love to learn. So we'll keep this interview in English.
Sure. Yeah.
Okay, so let's start with the basics. JEP 400 is all about making UTF-8 the default care set. Why don't we start by talking about UTF-8 and why it's important?
So this is not something providing a new API or platform or framework or something. This is to address the basic issue that has been long there since the beginning, I think, in the JDK. So this is providing the better interoperability between platforms in JDK regarding the default encoding. So it used to be the default encoding is determined by the underlying platform. So it's pretty much different on each platform. For example, on Linux or macOS, it's pretty much UTF-8, but especially on Windows, it's based on code page on each platform, on each Windows. And also, it depends on the user setting. For example, user select the English locale, but if you select the Japanese, the default encoding will differ. So that causes the interoperability issues. So this JEP is to address those issues by uniformly providing the default encoding as the UTF-8. That's the gist of this JEP.
So if I'm understanding you correctly, depending on the system or your configuration or your locale or even your individual settings, Java may pick up a completely different care set. Sorry, do most people say care set or char set? I've actually heard both.
It's up to you. I would just say char set, but people say char set or car set or something.
Okay, I'm going with char set then. So, so your system can actually pick up a different char set. And before JEP 400, what types of problems would that cause?
Let's say someone create a text file in some platform, and if you read that file with the API, like a file reader, that depends on the default encoding. So if you read that file, if you create that file on macOS, that is like a macOS editor, that is encoded in UTF-8. So if you read that file on macOS, it will use the default encoding as UTF-8, so it can be read correctly. But if you read that file in Windows, the default encoding is different. So, for example, if you read that file in Japanese locale on Windows, the content will be garbled. So we call that as mochibake. So that is the main issue before this JEP.
Got it. So I can see how that would definitely create issues because systems would be producing outputs that you weren't expecting even at runtime too. It wouldn't be caught at, let's say, compile time of an application.
Yes.
Okay. Interesting. Okay. And for listeners of this show who may be wondering if they're going to be impacted starting with JDK 18, what are the things they should be thinking about or looking at to figure out whether this is something they should be taking a closer look at?
Yes. So if you see this kind of mojibake, so it's not something that you would see right away. So it's not something that the JDK would throw an exception or something like that you would notice immediately. This is something that you will find out later, like looking at the file contents or something. To prevent that, I would recommend users to proactively try JDK 18 with this feature or the existing JDK with the runtime option. So there's a system property called file.encoding, which is kind of infamous encoding, file system property, but you can use that as the tool to specify the default encoding. So if you specify file.encoding to UTF-8 with the existing JDK, that would create the same environment as the JDK 18. So you could just test that with the existing environment.
Okay, so JEP 400 is a little bit like making the system property file.encoding equals UTF-8 as the standard standard property without having to type that in each time you run the Java runtime.
Yeah, that's correct.
Okay, now that makes a lot of sense. Okay, well, every guest that's on the Inside Java podcast has the ability to answer the question. Tell us something about a day in the life of Naoto Sato.
Where do I start? So yesterday was the St. Patrick's Day, right? So my one of my hobbies is baking, and I baked the Irish soda bread, which is very interesting and tasty. And other hobbies, I'm pretty much into cycling, so that's my hobby. Yeah, I do that all the time, I guess.
Great. So when not working on the JDK, you're cycling and baking soda bread.
Yes.
Well, Naoto, it was great to have you on, and thanks for covering JEP 400. We hope to see you in the future.
Great. Thank you very much.
Now, let's learn about JEP 408 Simple Web Server from its owner, Yulia Boz. These are clips from episode 22, where my colleague David talked to her in much more detail. His first questions asked her about an overview of JEP 408 and what some of the potential use cases are.
Simple web server, or as we describe it, a minimal HTTP static file server. It's really just that. So it's a server that serves a single directory hierarchy, and it only serves static files. We were not looking for any kind of feature-rich server because a lot of really good alternatives already exists. So whether that's server frameworks or production servers. So we really wanted to do the opposite of that, a minimal server. We also don't provide any features like encryption, access control, or authentication. So really the minimal design of that server is to avoid any confusion with those alternatives. There is many use cases where you might want some basic server functionality. A lot of those use cases are in the area of educational tasks or informal development or debugging. And we wanted to provide a tool that lets you hit the ground running with just one command really easily without any hurdles or ceremony to set up things to use that server functionality. There is 3 use cases that come into mind, although there's many different ones, but the ones that we thought of originally is web development testing. So let's say you want to have a local server client set up to simulate some responses and requests sending back and forth. It's also the case of web application or web services testing. That's where oftentimes URL maps to a function. So for example, app/browse maps to a browse function. And then while you're developing or implementing these functions, you might want to have some static files in place to have test the system and test the other implementations. And then the third use case, which we've probably all done before, is sharing files across the network. let's say you have a remote server and you want to browse a directory. So that's where such a basic server can come in handy as well. So yeah, we wanted to help people with that. The wider goal is that we wanted to make the JDK in general a bit more accessible with this out-of-the-box tool that you can start really easily, that is very approachable. And it's just a nice little add-on to have in the JDK.
Next, David asked her about there being both a command line tool, the J web server, and a new API edition, and when to think about the usage of one versus the other. Let's hear what Julia has to say about that.
Yeah, so I guess the most natural, or what we originally intended, was to have this command line tool. The name it has now that we ended up with is JWeb Server. So really just to have one command that starts the server in the foreground on the command line with minimal configuration. And that's really good for a lot of the use cases that we had in mind. I mentioned some of them. But then there are other cases. So let's say you want to use the simple server with some existing code, so programmatically either customize it further or add something that you've already written. Or let's say you want to take one of those components, the server or the handler, and adjust it or custom tailor it to your use case. So in that case, the command line tool kind of has its limits. And in that case, we wanted to kind of bridge the gap between this really simple command line tool and this more write-it-yourself approach of the old API. So we wanted to bridge that gap, and that's why we came up with a few API points to either retrieve the server components or to customize request handling further if needed. So yeah, as I already mentioned, the server implementation that is used by the command line and the API has three components. It's the server, the handler, and the filter, and I'll talk about that in a bit more. And basically those three components can now be retrieved in the API, and then we also have a couple of API points to customize those components and to make combinations and composability a bit better.
All right. To learn more about JET 408 and how to spin up a web server in JShell with just a few lines of code, check out JET 408 at openjdk.java.net and check out episode 22 of this podcast for the full interview with Julia. Now, let's turn to JET 413, code snippets in Java API documentation, and a chat that I had with Michel Trudeau. Michel, thanks for being on the show. Can you introduce yourself?
Yes, I'm responsible for the Java language and the tooling in the Java platform group for the development of those new features.
So thanks for being on the show. We are going to cover JEP 413. Why don't you start by just giving a summary of the JEP?
Yes, the summary is to introduce a new Java doc tag named @snippet for the Java doc standard doclet to simplify the inclusion of example source code in API documentation.
And it adds, if I understand this correctly, it adds both syntax highlighting as well as access to those snippets using an API. Can you talk a little bit about why this is important for developers, not just the folks that are working on Java itself?
Okay, why did we introduce that new JEP essentially? So a little brief history here. Up to now, to include a code snippet, a user would use the @code or the HTML pre-tag. The user had to escape special characters like angle brackets and ampersand. The user didn't really have Java code editor support while typing the snippet in the Java.doc comment. Also, the user didn't have a way to validate that code snippet, which led to maintenance issue over time, even code that didn't compile the first time if the user made a mistake in the code snippet itself. So these are all the reasons why we introduced that new feature. So the tag allows you to, this new @snippet tag, it allows you to include a snippet of Java code that is validatable. The snippet could be inline code or could be included from an external source files. That allows you to edit, debug, and maintain those snippets of Java code using your regular toolchain.
Cool.
Snippets can be compiled and tested as part of your build to make sure they are always valid. Also, those snippet source fragments can come from anywhere. As an example, from your test directory. Those snippets are found through the new command line argument called -- snippet path. When those snippets are coming from larger source files, we don't want to include the entire source files in the Java comments. So we introduced new special markup comments, and we can we mark region in the source file using those markup tags. And also the appearance for these rendered snippets can be customized using custom styles, for example, highlighting or replacing part of it, or as well, automatically link names to declarations in the Java doc.
Mm-hmm, mm-hmm. So to be clear, the snippet tag can reference an external file, which can be a complete Java program, compilable, and it can be tested in, let's say, a CI/CD system. But then an end user could declare a region as a special comment that then takes part of that file and makes that the code snippet inside the Java doc.
Correct. Exactly.
Wow,
Yes.
that's pretty cool. And none of this was possible before JEP 4.13, correct?
That's right.
I have a question about highlighting. So I saw that you can highlight, like, let's say, specific regular expressions or words. Is there plans to extend or expand on the highlighting system to use, let's say, out-of-the-box syntax highlighter configurations or something else in the future, or kind of adding on to that functionality? Or do you think it'll stay relatively consistent with what it is today?
We are evaluating different solutions here. So yeah, there may be plans to improve upon this in the future, depending what we are identifying. Yes.
Now, if a developer wants to get started using snippets with 18, how should they get started, or where should they go?
They should go to the documentation. We have a new guide called Programmer's Guide to Snippets.
Ah, nice. We will definitely leave a link to that in the show notes. I see that the compiler tree API has been extended for supporting the snippet tag. Can you talk a little bit about what that means exactly and how that enables the ecosystem to take advantage of snippets?
Yes, that API access allows tooling support to access those fragments. The tools that will access those fragments are IDEs, for example, which will allow to create, edit, and manage snippets.
Cool. Do you think end users will use that API in order to test their own snippets and say their continuous integration systems, or is this something more at like the IDE level only?
No, it's not only at the IDE level, it's really at the CI level as well, in order to make sure that those snippets are valid and compile and test successfully over time.
Okay, so this is definitely something that all developers should be taking a look at then.
Mm-hmm.
Awesome. Well, this is pretty cool. We ask the same question to all of our guests, and I didn't send this to you in advance, so what the audience is going to be interested in what you have to say. We ask all the guests, can you describe a day in the life of Michel Trudeau?
Yes, it's constantly tracking and features that are currently in process. And is also looking ahead a little bit about what we should be doing in order to keep Java cool, fun, and to keep innovating all the time.
Good. Well, hey, I appreciate you coming on the show to cover 4.13, and I look forward to chatting with you again.
Thank you.
Okay, now let's switch gears and learn a bit about JEP 4.21, deprecating finalization for removal, by going back to episode 21 with Brent Christian and hear in his words what this is all about. He starts with a review of finalization and the many known issues with it.
Finalization in Java goes back to the very beginning in Java 1.0. And that's also the same with garbage collection. If you're a developer of a certain age, you may have come to Java when it was new with some experience of C and C++. So garbage collection was a new feature you were getting. So the garbage collector will allocate your objects for you, deallocate them when you're done using them. So this was something new to C and C++ programmers. But to do anything really meaningful, your program needs to interact with things more than just heap memory. You need to probably read and write to the disk, maybe communicate over the network, maybe put some graphical elements on the screen. And so using these sorts of things is managed separately by the operating system. And we call those things collectively resources. These are things that need, special permission to talk to the hardware, and the system keeps special track of them. And so you let the operating system know when you want to use them, and you let the operating system know when you're done using them, so some other program can use them. This is something that the garbage collector is not aware of. That's something that, you need to specifically, when you're done using something like a file descriptor, you need to specifically close it. Finalization is a way for the garbage collector to get involved, to making sure these resources get closed. It was evident not too long after Java came on the scene that finalization had a number of problems with it. One of the problems with finalization that I think most people are aware of is that there's a unpredictable latency to when a finalizer will run. A garbage collector's most important responsibility is managing heap memory, and does that with various priorities. And so running finalizers does not always fit in what its main job. So sometimes it can be quite a while before a finalizer runs. And in fact, in the specification, it's not guaranteed to run at all. A finalizer is basically allowed to run any code. And one of the most significant things that it can do is it can take the reference to the object being finalized and make it reachable again. It can stuff it into perhaps a static reference, and then this object that was about to die comes back to life. It's resurrected. And this comes into play in some of the security problems that finalization has.
Brent goes on to talk about a host of other issues with finalization, but I think by now you get the picture. Next, he turns to the alternatives to finalization.
Kind of the gold standard, I would say, in Java for resource management came in JDK 7 with the try with resources statement. So instead of trying to account for exceptions yourself using a finally block, the try with resources statement allows you to declare your resources at the beginning of the try and just write the code for what you need, how do you need to use those resources. And then those resources are guaranteed to be closed, whether the code executes correctly, or if any sort of exception happens during your code, or if an exception happens during closing one of the resources. It's the safest way to write code with resources. All that you need to do if you want to write a class that can work with try with resources, is implement the auto closable interface, which is just one method close, and then your classes can be used with try with resources. It's easy to use. Yeah, cleaners is a similar in spirit to finalizers, but it has almost none of the disadvantages of finalizers. So to use cleaner, you can register your object with a cleaner and write a cleaning action, which is just a runnable. And when your object becomes unreachable, the cleaner will run the cleaning action. And in your cleaning action, you can have any code that releases resources.
Now that Brent's talked about finalization and its alternatives, he covers JEP 421 and what that actually means to Java 18.
So JEP 421 is really putting the next stake in the sand as far as moving away from finalizers and eventually taking them out of the JDK. And so it's not a lot of actual code change. I mean, the behavior of JDK won't change in this respect, but it's really kind of an alert to developers that if you use finalizers, to get serious about moving away from them. This JEP also adds a command line option to disable finalization. Definitely not something you'd want to use anywhere besides a very controlled test environment. There's still finalizers in the JDK itself that are supposed to be running, so those would be disabled as well. But if you're able to put together kind of a good test of your application, you can test it once with finalization enabled and look at what sort of resource usage you're seeing, and test it again with finalization disabled. If you're seeing that things aren't being cleaned up, behavior of that nature, that's a good sign that you should do some more in-depth investigation of what finalizers might be used when your application is running. In JDK 18, we also added a new JFR event called JDK.Finalizer Statistics that will tell you for every class that runs a finalizer, it will tell you how many finalizers of that class were run, how many still remain yet to be finalized. So that can be a very important metric for finding finalizers when your application's running.
There's more in Java 18 worth taking a look at, but because they're pretty heavy on the plumbing side or further incubator preview features, we'll skip them for now. You can, of course, check them out at openjdk.java.net, and you should always start at both inside.java and dev.java for the latest Java news and information directly from the source. Thanks for tuning in to this special montage episode of the Inside Java podcast. Go check out Java 18 today, and I'll see you next time.